Now the title might seem a little long, classification of matter by physical state, chemical composition, and more, but hopefully you've heard of a lot of these terms before. In this Tobacco University video, we'll help you understand each in a little bit more detail. All right, let's start with classifying of matter. Well, by physical state, we can classify it. That'd be solid, liquid, gas, or plasma. Chemical composition of pure substances, such as elements or compounds, or a mixture, which could be homogeneous or heterogeneous. These categories help describe matter's behavior, structure, and interactions in both physical and chemical context. For example, pure iron, which is an element in the solid form, differs from salt water, which is a homogeneous mixture in a liquid form, in both in state as well as composition, as I described there. So again, we're looking here at a kind of a flow chart or breakdown, but first of all, it's classification of matter by state and physical composition. So that physical state, let's dive into just a little bit more detail of the solid, liquid, gas, and plasma. It does exist in these determined arrangements. Solid is that defined shape and volume of tightly packed molecules with minimal movement that kind of vibrate in place, such as ice and iron. Liquid has a defined volume but no defined shape. The particles flow and kind of slide past each other, such as in water and oil. And gas has no defined shape or volume, and particles move freely and are able to spread out, particularly impacted by temperature. Plasma is ionized gas with free electrons and ions, highly energetic and conductive. Lightning and solar plasma would be examples of that. Now, chemical composition of pure substances. This is where matter is further classified based on this as with pure substances as well as mixtures. But pure substances do have a uniform and defined composition with constant properties throughout. Elements are composed of one type of atom defined by the number of protons. For example, H stands for hydrogen, Au for gold. And you can look at the periodic table of elements for some of those. Compounds are formed when two or more of those elements chemically bind together in fixed ratios with unique properties distinct from the elements that they were composed of. For example, water, H2O, has very different properties than just hydrogen or just oxygen alone. We see the same thing with carbon dioxide. Now we're looking at our mixtures. They are combinations of two or more substances that retain their individual properties and are not chemically bound, and they can vary in composition. Homogeneous mixtures have a uniform composition throughout. Salt water would be an example, air would be another example, solutions of this common type. Heterogeneous mixtures are non-uniform composition with visibly distinct components, such as sand. We could even consider it to be water and solid, would be heterogeneous mixtures. They basically have separation that you can clearly see within those. Now, additional classification, we can classify things based on particle size within mixtures. So when we're looking at this, we have solutions, which are particles are molecular or ionic in size, are fully dissolved. For example, sugar in water. You have a sugar-water solution as a result. Colloids are large particles, 1 to 1,000 nanometers, dispersed, but not necessarily settled. They scatter light, such as milk or fog. And then we have suspensions, which are defined as large particles being greater than 1,000 nanometers that settle out over time. And this example would be muddy water. If you take muddy water and shake it up and then let it sit over time, you'll start to get that mud will kind of accumulate at the bottom, because that is an example of a suspension. And then lastly, looking at the physical properties here, physical properties of matter can also be classified by measurable traits like density, conductivity, or magnetism. You can also look at metals or nonmetals, conductors or insulators. So a lot of different things to look at. And also, as we become more familiar with the periodic table, we can clearly find an element and define whether it's in the metal, nonmetal, or this kind of in-between metalloid category. So all of this kind of comes together to hopefully clarify things, reiterate some terms that we're going to be utilizing in other aspects.